Okay guys, so now what I'm going to do is try to solve page 46. Page 46, and I'm going to do problem number 47. Problem number 47. So, when I look at this problem 47, what do we have? They are telling you that you have a line, and this line is going, I'm going to call that the line number 1, and it's going through the point negative 5, 7, perpendicular to another line, that the line is equal y equal negative 2. There is two, and you have to find the expression of the line number 1. So there is two options for you. First, you are going to use your formula and say, you know what? Because it's perpendicular, I know that my line number 1 is going to be equal to minus 1 over m2. So now I can look at my line number 2. If I look at the expression of my line number 2, what do I have? I can see that this line number 2, and I'm going to write in yellow, this line number 2 right here, if I try to compare with what is supposed to be the expression of a line, m2x plus b2 for my line number 2, I realize that there is no x, which means the slope of your line number 2 equals 0. Alright, if the slope of the line number 2 is equal to 0, you're trying to substitute the value of m2 inside this expression, and your calculator is going to tell you, well, it's undefined. Let's think about what does represent the slope of a line. If you have, and let me go on another page. If we're going to define a slope, it's if that is the earth, okay, and I can have one slope, or I can have another one, which means this, and then I can have another one, which should be this one, and I could have even another one, and let's try to change the color to have something nice. I could have something like this, okay. When I'm going from the surface of Earth and I'm changing slope, I have my slope which is increasing, okay? And it's increasing so much that at some point I can have a vertical line right there, okay? I can have a vertical line. And here's the thing. When you have that case, that means the line number 1 is vertical, okay? That means the line number 1 is vertical. Let's try to see if that reasoning is okay or not. Well, for that, let's go back and let's take a look at y equal negative 2. When you are looking at y equal negative 2, what you can say is y does not depend on x. That implies that no matter what value of x, y will not change. So if I decide to graph y equal negative 2 for any value of x, for this one, y equal negative 2. For this one, y equal negative 2. This one, negative 2. This one, negative 2, etc., etc., etc. Okay? And that showed you that your line number 2 is horizontal. And if the line number 2 is horizontal, because I know from the get-go that the line number 1 is perpendicular to the line number 2, well, if the line number 2 is horizontal, because line number 1 is perpendicular, that implies that the line number 1 is vertical. And the line number 1 is being vertical, going through the point negative 5, 7. That implies that the equation of your line number 1 is x equal negative 5. The reasoning I made for an equation with y equal negative 2, you could have exactly the same reasoning for an equation for a line where x equal whatever. If you look at the problem number, if I'm correct, it is the problem number 53. If I look at the problem number 53 now, okay, on the problem number 53, we have to find a line going through the point 1, 2 and perpendicular to another line x equal 3. Well, when you're looking at x equal 3, what you're going to say is x does not depend on y. That implies that no matter what, x will be always equal to 3. So if I decide to graph this line number 2, I'm going to have no matter what value of y, I will have x equal 3. So that means my line number 2 is vertical. And if my line number 2 is vertical, that implies that my line number 1 is horizontal. And if my line number 1 is horizontal, going through the point 1, 2, that means my line number 1 is y equal 2. Alright, I hope everything will be easier now. See you in class.